Welcome to lesson 4.2/8.2, solving equations using multiplication or division. We're going to be solving one-step equations again in this lesson. And as we go through that, you're going to use the multiplication division properties of equality to produce equivalent equations, which really gets to the idea of whatever you do to one side, you do to the others. If you multiply one side by 2, you multiply the other side by 2. If you divide by one side by -6, you divide the other side by -6. That's what we're talking about there. You're then going to solve equations using multiplication and division, and also do that applying it to real life problems. Now, looks like there's a whole lot of things to remember, and there are, but it's all stuff we've been doing, okay? It's taking the ideas of multiplying and dividing integers and fractions and decimals, all those different types of numbers, and taking all those rules and then putting it together with the equation stuff. So I thought it'd be good just to review some of that real quickly. So if you're multiplying fractions, remember you multiply straight across and reduce, or cross cancel, then multiply. And of course you always want to double check that if you need to reduce, okay? That's just kind of standard now. When you work with fractions, always check to see if you need to reduce. When you're dividing fractions, multiply by the reciprocal. Then you go back to these rules, okay? Remember, it's keep, change, flip. So you keep the first fraction, change division to multiplication, and flip the second fraction so you have its reciprocal or multiplicative inverse. If you're going to go to decimals and multiply decimals, you just multiply those decimal numbers. Just do the multiplication, then count up how many decimal places were there in the factors. Start on the right side of your product or your answer and move to the left how many times you need to make that same number of decimal places as you had in the factors. Dividing decimals, it's a lot to write. It's actually easier to say, I think. So we want to get any decimals that are in the divisor out. So we move the decimal point to the right till they're gone. That's multiplying by 10 for each move. So however many times you move the decimal point, you do the same thing in the dividend. You move the same amount to the right, then that decimal point goes straight up to the quotient. Do your division till you have to be done. However, it asks for a decimal answer, if it's rounded, as a fraction, whatever it needs to be, okay? Then you come over here. If you multiply two positive numbers or you divide two positive numbers, you get a positive answer. You multiply two negatives or divide two negatives, you get a positive. So if you're multiplying or dividing numbers with the same sign, you get a positive answer. If you're multiplying or dividing numbers with opposite signs, so one positive, one negative, or one negative and one positive, you get a negative answer. Then in terms of variable or equation solving things, our goal is always to isolate our variable, get it alone, use the opposite operations to solve. So that means in this lesson, if we see multiplication, we're going to do division to solve. If we see division, we're going to do multiplication to solve, at least initially in our thought process. We may end up, multiplying by a reciprocal instead, but the initial thought process is divide. And then how do we divide? We might have to do some multiplication. And then, of course, we keep equations balanced, which means whatever we do to one side of the equation, we have to do the same thing to the other side. All right, let's take a look at a few examples where we're going to have to apply these multiplication and division rules to help us solve. First one, c over 8. Remember that fraction bar really means division. So c divided by 8 equals -7. It's the same as writing the problem like that. There's our division symbol. However, we just don't use that division symbol much anymore because we can write things as a fraction. So I'm going to erase that. So that means we're seeing division. So if we see division, that means we need to do multiplication to solve. So I'm going to multiply both sides by 8. And really what I'm doing is multiplying by 8 over 1. Because then when we see, multiplication, you multiply across, but if you see an easy cross cancel, there we go. And over time, you'll probably see most people just write times 8, not 8 over 1. Just kind of a shorthand, and then we multiply by 8 over here. So the 8s cancel themselves out, reduce down to 1. So we're left with c equals -7 times 8 is -56, because a negative times a positive is negative. 7 times 8 is 56. All right, let's come over here. -32 equals -5p. Now, you're saying, I really like the variable on the other side. Okay, flip it around. If you don't care, then don't worry about it. Notice I didn't change the order of anything. All I did was take the right side, put it on the left, and the left on the right. We see multiplication here. So if we see multiplication, a number and a variable bumped right up against each other, that's multiplication. So that means we have to divide both sides by -5 in order to solve. -5 divided by -5 is 1, and we don't usually write the 1 with the variable. We just write p equals negative divided by negative is positive, 32/5. Can that be reduced? No, nothing goes into 32 and 5, and I'm fine with an improper fraction as long as it's reduced. All right, over here we see -5/9 m equals 25. So we see multiplication, right? So our thought is divide. All right, so I divide this side by -5/9. When you divide a number by itself, it cancels itself out, becomes 1. Okay, so that leaves m over here on the left side. But normally we don't divide fractions. What do? We multiply by the reciprocal. So instead of dividing by -5/9, we're going to instead multiply by that reciprocal. So I'm going to take off that division and just say I'm going to multiply by -9/5. Trying to give a negative sign and a fraction there. And 25 just becomes 25/1, because any number that you want to turn into a fraction, just put it over 1, right? All right, so now, if you want to just multiply across, 25 times 9, if you need a tool to help you, you can grab a calculator. 25 times 9 is 225. All right, so we've got 225. This is a negative times a positive, so if you need a negative out there. So 225/1 times 5 is 5. Now, let's see, how many times does 5 go into 225? Well, it goes in 45 times. So our answer really is m equals -45. Now, some of you may have said, well, I could cross cancel, right? And say, oh, 5 goes into 5 once, 5 goes into 25 5 times. 5 times -9 is -45, 1 times 1, so there's my -45. Either way is fine, whatever you're more comfortable with. All right, let's take a look down here. 4.5 equals -8/9 k. Now we see an improper or a mixed number. We need to make that improper because we can't multiply or divide with mixed numbers. So let's do that. Remember, we work from the bottom up. 2 times 4 is 8 plus 1 is 9 over our original denominator. So now we have 9/2 equals -8/9 k. So that looks like multiplication, right? What do? We divide. Divide by -8/9. That's going to cancel out because I'm dividing a number by itself. That makes it 1. But instead of dividing by this, I really want to multiply by this reciprocal on this side. And really what's happening is I've got this problem going on, which means I multiply by this second number, okay? Don't flip 9/2. Flip whatever you divided by on the side with the variable. Grab my eraser. And if you need to write 2 steps, then write 2 steps. All right, so I've got -9/8 that I'm multiplying by. In fact, let's do that, at least for this example, so you see what we're doing here. -8/9, so I'm going to multiply 9/2 times -9/8. Fraction burn, there we go. Does anything cross cancel? No. So I'm just going to multiply across, and I get -81/16 equals k. And it flips that around, -81/16 for k. Like I said, if you're getting good at this and understand, okay, dividing is the same as multiplying by the reciprocal, as long as you're multiplying by the reciprocal of this, of whatever you divided by over here with the variable, then you can just kind of write that in there, all right? Or maybe you look at it, one other way you could look at this is a way to write the problem, is you see that multiplying by the reciprocal right away. Here's our problem. I'm going to write the 9/2 part just because I know we're going to need it. Oh, I can write it out here. So if I multiply by negative 9 over 8, those 9's cancel, those 8's cancel, that cancels. And I just do the same thing over there. And I get negative 81 over 16 equals. Okay. So another way to think about it, you automatically see a fraction, say, I'm just going to multiply both sides by the reciprocal. But why do you do that? Well, it's because really it's dividing, and what is divide? How do we divide fractions? We multiply by the reciprocal. So hopefully that's making a little bit more sense now. Okay, now for the sake of space, now leave that. We'll fit it in here. Okay, here we go. Negative 0.3y equals 2.4. We got decimals. We see multiplication, so that means we're going to do a little division to solve. Negative 0.3, negative 0.3. So those cancel out there. We got y equals. Now we've got to do a little division. We have a positive divided by a negative, so we know we're going to have a negative answer. When I actually write this out to solve, I don't write the negatives in the problem. They get in the way. So now, I'm just going to do 0.3 is my divisor. 2.4 is my dividend. Dividend over divisor. Here we go. We got a decimal. Got to get rid of it. I move it once to the right, which is the same as multiplying it by 10. So if I do that to the divisor, I do the same thing to the dividend. And then it goes straight up. And how many times does 3 go into 2? Oh, it doesn't. How many times does it go into 24? 8. 8 times 3 is 24. Boom. 0. Oh, our answer is just negative 8. We don't have to put that decimal point on there because we don't have anything else to the right of it. Okay, now we're going to take a look at a few examples involving some word problems, trying to apply some things to real life. So the record low temperature in Montana is negative 70 degrees Fahrenheit. That's cold. It's really cold. Wow. The record low temp in Montana is 1.4 times the record low in Nevada. What's the record low temperature in Nevada? Well, let's look at what we've got. Well, Nevada, we don't know Nevada's. That's our unknown. But 1.4 times Nevada's gives us Montana. Because Montana means equals. So Montana's equals 1.4 times Nevada. So Montana's was negative 70. 1.4 times Nevada, I'm going to use N for Nevada, should give us our answer. Well, we see we've got multiplication. What do we do to solve? We divide. 1.4 divided by negative 70. Well, we know our answer is going to be negative, and I just already flip it around for my variable first. You just get so used to doing this, you just start to automatically do it. So, whoops, no negative there. There we go. Negative divided by positive is going to be negative. Okay, but let's do our division. 70 divided by 1.4. I have a decimal point. I need to move it over here. Now, my decimal point for 70 is out here on the right side. I move it over one spot. I have to put in a 0. And then I extend that a little bit, put my decimal point straight up. All right, how many times does 14 go into 70? Right, it goes in 5 times. 5 times 14 is actually 70 exactly. But we're not done. The temperature's not 5. There's still a whole 0 here that we put in that we have to account for. 14 goes into 0 times. Okay, so that means negative 50 degrees Fahrenheit is the record low temperature in Nevada, which I might add is also very, very cold. Okay, another one. A stock has a return of negative $1.40 per day. That means it's losing money each day, $1.40 per day. Write and solve an equation to find the number of days until the return is negative $12.60. So, if it returns $1.40 per day, wouldn't you take $1.40 times the number of days to get the return amount? So in other words, negative 1.40 or 1.4, we use D for days, equals negative 12.60. Or you could use 12.6. When you're doing the quick math part of it, feel free to leave the zeros off. And in fact, because we have multiplication, we're going to do division to solve. Because those zeros are just placeholders. They're just going to drop off. Negative divided by negative is going to be positive. Well, and that makes sense. We don't have negative days. We only have, we have 5 days, 10 days, 9 days, whatever it is. So it's going to be positive. So D is going to equal something. let's go figure out what. 1.4, it's on the outside, 12.6 on the inside. I do that just, unless we need it for something, we don't need those zeros in there. So decimal point moves 1 to the right, I multiply it by 10. So I do the same thing to the dividend. Then it goes straight up. 14 goes into 12, 1, no, 12, no, 126. Well, if you're not sure, grab your calculator, handy tool to help you. 126 divided by 14. Ooh, goes in evenly, it goes 9 times. 9 times 14 is 126. That's 0, so that means D is equal to 9 days. It'll take 9 days for it to be worth negative $12.60 or have lost $12.60. All right, so hopefully now you've seen how we can use the multiplication and division properties of equality to help keep our equations balanced, solve with them both in regular equations and in real life problems. Thanks for watching.